Mastering peer-to-peer networks. In a decentralized network, no one is accountable for data consistency, leaving integrity to chance. Who is responsible for ensuring data consistency across the distributed nodes in the peer-to-peer network, and what mechanisms are in place to guarantee data integrity and consistency in a decentralized environment where nodes can join and leave the network dynamically? In a peer-to-peer network, ensuring data consistency across distributed nodes is a crucial aspect of maintaining operational excellence. Since nodes can join and leave the network dynamically, it's essential to have mechanisms in place to guarantee data integrity and consistency. The responsibility for ensuring data consistency lies with the distributed nodes themselves, which work together to maintain a consistent view of the data. This is achieved through a combination of mechanisms that ensure data integrity, consistency, and replication. One approach to ensuring data consistency is through the use of distributed hash tables, DHTs. DHTs are a type of peer-to-peer network that use a decentralized approach to store and retrieve data. Each node in the network is responsible for a specific portion of the data, and the DHT ensures that the data is distributed evenly across the network. When a node joins or leaves the network, the DHT is updated to reflect the change, ensuring that the data remains consistent across the network. Another mechanism used to ensure data consistency is through the use of version numbers or timestamps. Each node maintains a version number or timestamp for each piece of data, which is updated whenever the data is modified. When a node receives an update to the data, it checks the version number or timestamp to ensure that it is the most recent version. If the version number or timestamp is outdated, the node will not accept the update, ensuring that only the most recent version of the data is accepted. In addition to DHTs and version numbers or timestamps, peer-to-peer networks often employ consensus algorithms to ensure data consistency. Consensus algorithms, such as Byzantine Fault Tolerance, BFT, or Paxos, are used to ensure that all nodes agree on the state of the data. These algorithms work by having nodes propose and vote on updates to the data, ensuring that all nodes agree on the most recent version of the data. Replication is also a key mechanism used to ensure data consistency in peer-to-peer networks. Data is replicated across multiple nodes to ensure that it is available even if one node fails or leaves the network. This ensures that the data remains accessible and consistent across the network. To further ensure data consistency, peer-to-peer networks often employ data validation and verification mechanisms. These mechanisms, such as digital signatures or checksums, are used to verify the integrity of the data and ensure that it has not been tampered with or corrupted. In addition to these mechanisms, peer-to-peer networks often employ robust membership management and node reputation systems to ensure that nodes are trusted and reliable. This includes mechanisms for node authentication, authorization, and accountability, which ensure that only authorized nodes can join the network and participate in the data maintenance process. Finally, peer-to-peer networks often employ monitoring and logging mechanisms to track changes to the data and detect any inconsistencies or errors. This allows for quick detection and correction of any issues, ensuring that the data remains consistent and reliable. In summary, ensuring data consistency in a peer-to-peer network requires a combination of mechanisms, including distributed hash tables, version numbers or timestamps, consensus algorithms, replication, data validation and verification, membership management, and monitoring and logging. These mechanisms work together to ensure that data is consistent and reliable, even in a decentralized environment where nodes can join and leave the network dynamically.